It's the year 2000s. Flip phones were everything. The click was iconic. The compact size was revolutionary. Everybody wanted one because it was the symbol of being cool, stylish, up to the trend, and connected to the modern world. However, as time passed by, technology eventually evolved. Flip phones were eventually replaced, turned into a sleeker, larger, and flatter screen, the dominant force that our hands have today. But little did we know that flip phones were not exactly done yet. Now, it was just getting started, as the year 2018 and up until this year, something was being developed and produced, a reimagined foldable cell phone. The future brought them back. Follow me as we investigate and appreciate the chemistry behind the latest buzz. The foldable cell phone. Now, the foldable cell phone has two types. First is the book style. When it is folded, it almost looks like your regular cell phone. But when it is unfolded, however, the screen size, it doubles. It gives you an almost tablet-like experience, and this increases productivity, entertainment, and doing tasks. And since when you fold it back to a regular phone, it makes it easier to bring around with you as compared to bringing around a compact tablet. Next is the flip style, which is designed just like your classic flip phones. It folds vertically and makes it much more easier as it becomes smaller to carry around when it is folded. Now let's get to the important and most interesting part of the presentation. How exactly do foldable cell phones fold? Let me introduce to you the polymer that started it all. Scientists figured out a very special type of plastic that will be able to bring foldable cell phones into light. Our underdog hero, Polyimide. Polyimide has exceptional properties. Its particles are bonded very tightly within themselves, which is why, even as a thin film of plastic, it stays strong and flexible. It is also exhibiting high thermal stability. It can withstand temperatures higher than 500 degrees Celsius. It also has high mechanical strength and a superior electrical insulation, which makes it a great shelter for the marvelous technology behind the screen display. The OLED, the organic light emitting diode. Now, the OLED is composed of multiple layers, and we can think of it like a cake, where each layer has its own different, unique functionality that contributes to the amazing high quality and color accurate display that modern technology, flip phones, and even TVs of the modern time uses today. Let's dive in to two important layers. First is the emissive layer. In an OLED display, when you look closely, they are composed of tiny pixels. Each pixel of the screen is made of 3 subpixels made out of emissive polymer materials. We have a red, green, and blue emitting polymer, and when electricity passes through the emissive layer, these 3 subpixels emit light in a particular wavelength and intensity. Next is the transparent electrode layer, more known as the anode. They have to be a transparent metal sheet so that they can allow the display from the emissive layer to reach the human eye. There are 2 common materials in which the transparent electrode layer is used. which is the indium tin oxide, or the ITO, and graphene. The problem with indium tin oxide is that indium is rare and expensive to process, and the compound itself can be brittle and it might tear after much folding. In the other side, graphene is an organic allotrope of carbon. Its honeycomb-like structure provides flexibility, and the conjugated backbone, which is simply an alternating pattern of single and double bonds, gives it high conductivity. And since this is organic, it's more abundant to Earth as compared to indium. But the problem with graphene is that it's a bit tricky to mass produce efficiently, for the treatment of the organic material can be quite costly. Now, to demonstrate on how the OLED works is that we start with the cathode and the anode. The cathode is the negative terminal and it injects electrons, while the anode provides electron holes as the positive terminal. The negative and positive travels towards the emissive layer and by virtue of attraction creates electricity. And this electricity is the one that activates and manipulates the RGB molecules of the emissive layer into a specific color combination for one pixel, and when it's combined with other pixels would create a beautiful set of colors that we see on screen. This is how it would be demonstrated. For example, for RGB that is all in equal intensity would create white. When there is blue is absent, it creates yellow. Or when red is absent, it creates blue. It's almost like pixel art. However, with how little each pixel is, when it reaches our human eye, it's not exactly the blocky pixel art that we see, but a very high quality and color accurate image. Now, we discuss on how OLED is integrated onto polyimide. There are three common processes. First is the spin coating, which is a common technique that uses centrifugal force that spreads out a liquid that is dropped onto the forces evenly. Think of it like the CD that we see. The CD is the surface that spins in high forces, high speed. And when you drop a liquid onto the middle, the liquid would eventually spread out evenly. And the next is the vacuum deposition that essentially utilizes evaporation. An organic material is placed in a container, heated until it's vaporized. And when it is vaporized, its vapor travels through the vacuum chamber and it accumulates into a thin layer onto the substrate. Next is the inkjetting, which works just like an inkjet printer, where the OLED layers are sprayed onto the substrates, just like how ink is sprayed onto paper in printing, similar to how this image of a gingerbread is being coated with very specific points of the icing. It has to be very, very precise, so it puts different materials into tiny specific spots. Now, the question that users ask, as critical as humanity is are foldable cell phones tough enough? Scientists worked hard to figure out a way to answer this concern, and they found inspiration in a very unlikely source. They found it in oobleck. It's a non-Newtonian fluid which has a key behavior that behaves like a solid when force is applied, but behaves like a liquid with gentle force. Scientists modified this dynamic chemical bonding and created a special protective film that they put onto the foldable screen. So when the screen is folded, the dynamic chemical bonds, they are easy to separate and requires little energy. The repulsion makes the particles just slide past through each other. However, with sudden impact done to the screen, the dynamic chemical bonds become harder, it requires more energy to separate, which makes the impact resistance much more higher, much more efficient. Now, what about the battery? Well, the battery for foldable cell phones still uses the traditional lithium-ion batteries that regular cell phones uses. But this time, since there is a folding factor to be considered, it is split into two smaller batteries, one on each side. It's still yet to be created, a foldable battery. Now let's talk about the challenges. First is the durability. In durability testing, it is seen that foldable cell phones can develop micro cracks with enough folding, enough scratching, and bending. It is also prone to degradation since organic materials can degrade with the presence of moisture and oxygen. Next is the crease formation. By the folding line of the phone, there is a visible crease, and engineers are working hard to make this less visible when the phone is folded. And of course, the cost. It takes quite an expensive amount to treat the organic materials to become functional for the foldable phone. And as for the future trajectory of foldable cell phones, they want to have a more durable coating so that it can withstand scratches, fingerprints, sudden impacts. And they want to aim for brighter, longer-lasting OLEDs, where research is happening to make OLED molecules last longer since it has a tendency to fade over time. And lastly are design improvements. Hopefully one day, the work is being made to make flexible batteries and more foldable designs like rolling phones or maybe wearable screens. So to wrap this up, let's go back to what we have thought in the introduction, where at first, foldable phones seemed like just another trend, just another way to use up nostalgia by flip phones and to profit from them. It's something flashy to grab attention, but when we look deeper into foldable phones, there's clearly something more to it. Folding isn't just for show. It's about adapting, innovating, and making the impossible happen. And maybe that's what makes foldable cell phones so important and powerful. They're proof that sometimes bending doesn't mean breaking. It means moving forward.